Welcome to solverfy.
Hello, my name is Margaret, and today I'm helping you with some problems from Chapter 8 of Chemistry, the Molecular Nature of Matter and Change, the 7th edition. And I'm helping you right now with a problem, number 29, and it's asking us for partial orbital diagrams and condensed ground state electron configurations for several elements. So let's get started. So for these, I like to start off with the electron configuration because I think that is helps make the orbital diagrams easier. So let's start with manganese. So manganese is in the fourth row, but it's in the D block, so it's a 3D element. And so if we circle back, its most recent noble gas is argon. So we'll put argon in brackets because we're doing the condensed electron configuration. And so if we keep going the way we normally would with a normal electron configuration, then next would be 4s2. Then 1, 2, 3, 4, 5. It's 3d5. And that's it for that one. Next we have phosphorus, which is a 3p element. So its most recent noble gas is neon. So after that, it's 3s2 and then 3p3. And then lastly, we have iron, which is the element right after manganese. So it's going to be argon in brackets, and then 4s2, 3d6. So now that we have these, we can move on to the orbital diagrams. So for manganese, all right, so when you do the partial orbital diagram, so partial orbital diagrams, you essentially take whatever row the element is in, you draw out all those orbitals, and then you fill in all of the electrons that it has for that row. And the reason the electron configuration is nice is because it's essentially all of the electrons that you have to use are going to be all of the electrons we've listed outside of the brackets. So for manganese, so we have the fourth row to work with. So we have 4s, 1, 2, 3, 4, 3d, and then 4p. Now to fill, okay, we have 4s, so we have the up and the down. And I'm using different colors so you can see the electrons a little better. I'm trying to keep this all into one window for you, as opposed to breaking it up into several whiteboards. And so I'm having to draw the boxes a little smaller. So for the 3D, we have 1, 2, 3, 4, 5. Because they're all going to fill an orbital first before it comes back to pair. So moving on to phosphorus. We have 3s. And that's a lot of space for that orbital. Whoops. And then we have 3p. So we have one up and then one down in the 3s. Then we come in with 1, 2, and 3 for the p. Then our last one, iron. We have 4s, 3d, and then 4p. In our 4s, we have one up and one down. And then in our 3d, we have 1, 2, 3, 4, 5. Then we still have one more, so we come back to the beginning to have our first pair.